Hello everyone, this is Mr. 2X. So in this video we'll talk about the graphical construction of inverse functions. So in the previous one we used and we learned about an analytical property of inverses. And what we'll do in this video, we use the functions that we worked on in the previous video and we'll graph them to see if we cannot find a hidden property of inverses. So let us recall that in the previous video we worked on those functions listed here, and as already said, we have found an analytical property of it. We found out that when we composed those two functions f and g, whatever order, we had x as our end result. So maybe it will be useful to also graph the identity function on each graph and see if we can find something useful. So we now draw four different graphs with each time the graph of f and g, and also the graph of the identity function. So you can do this exercise, you can pause the video and try to find the hidden pattern behind those inverses. So for the first and two function f and g, we have this construction. For the second one, 2x and x divided by 2. For the third one, 1/3 x plus 1 and 3x minus 1. And x divided by 2 plus 2 and 2x minus 4. So there's something there. There's a hidden pattern behind this, all those functions, a common property. Did you find it? So if you didn't find it, don't worry. Maybe those two other examples will help you to find it. So did you see it now? So the property is that if you know the graphic of the function f, of a function f, or of its reciprocal of inverse, as we say in mathematics, and if you want to plot the graph of its inverse of its basis function, you need to use the line y equals x as an orthogonal symmetry axis. Let's see, we use now GeoGebra, and we'll see if we can reconstruct it by using this property. So I will use GeoGebra now. So the first example was with x plus 1. Let's see what it gives us. So I've plot the function between x equals minus 10 and x equals 10, and you see the line is exactly the line with the equation x minus 1. It passes through the point 0 minus 1, and the slope of this line is 1, 1, so it's 1. Okay, so the property functions here. The property is true for this function. So let's see what it gives us with 2x. So we'll animate this. So did you see? It gives us the line y equal to x. How can I see that? Because the line passes through the point, the origin of the graph, and has slope to, so you see the construction to 1, 1/2 to 1. So the slope of this line here in the dotted line in black is 2. So it's 1/2, sorry. So it has to be 1/2 x. And it's the inverse function of 2x as seen in the previous plot. So now let's see what it gives us when we use the function equals divided by 2 plus 2. as in one of the last examples. Let's see what it gives us. And did you see? It's always symmetric to this line, and the construction of it gives us the line 2x minus 4. Why 2x minus 4? It passes through the point 0 minus 4, and if you see this, you can calculate the slope, so you see the movement 1 2. It's always 1 2 1 2, so the slope must be 2. So this function has the graph of this the equation of this graph, sorry, is y equals 2x minus 4, as seen in the previous video and as seen in the previous graph. And you can use it for and this property to construct the inverse of a function if you know the graph of its basis function. So maybe we can use so maybe we can use x to the third. We know that the inverse, the reciprocal, as we also say in mathematics, is the cubic root of x. So let's see if using the graphical property, if we can reconstruct the graph of cubic root of x. Let's see if what it gives us. Do you see? It has to be cubic root of x. Let's see what it gives us if it goes this way. You see, it's the graph of the cubic root of x. So here you did fine. You learned about the graphical construction of inverses. So it works always not so really. We'll learn that in the next video. We'll see some examples of functions that have inverses, but there is a problem with the inverse. So it works, but not always. So if you find this video useful, like it, thumbs up. And if you think that it can help somebody learn of comprehend the graphical construction of inverses, transfer to it. And otherwise, I'll see you later. Bye bye.